So there are a bunch of points I want to make. I'll try to make them quickly. First of all, I really appreciate Ken Wheeler and Fractal Woman, both very smart people. They have fantasy football, but if they had fantasy metaphysician, well, then you'd both be on my team. With that being said, Electric Universe people are really dumb. Really dumb. Um, if someone challenges your position and your only response is "shut up, you're evil," well, you're in a religion, okay? And that's basically what the Electric Universe is. It's a religion. You think that you're all so smart and so cool for being against the status quo, whatever mainstream physics. Um, but you're not smart unless you can actually explain A, why the status quo is wrong, and B, why you're right. Because you have to do both. You know, you can say someone's wrong all you want, but out of all the alternatives there are, which one is correct? See, all of us understand that the status quo physics is wrong. But why? Why? That's the first step. Understanding exactly why they're wrong, and basically, Electric Universe people haven't even got to that step yet. Um, really, the first way to start understanding how they're wrong is by understanding monism and dualism. And lately, Ken Wheeler has been talking a lot about those topics, ontology, which is good. Keep doing that. Thank you. Because look, um, everyone uses the same data. All right, all right. It has nothing to do with, oh, well, their data is bad and our data is good. No, everyone's got the same data, right? It's the analysis. They have a different analysis. Their analysis is wrong. So you have to show why your analysis is correct and theirs is wrong. The thing about mainstream physics today is that, well, one way to put it is that they do not draw a distinction between data and analysis. They say, well, all you need is data, but there's always an analysis. There's always an analysis. So the lack of distinction between the two shows that they're forced to only perceive the data, analyze the data in one way. And that's why it's dogmatic. That is the definition of dogma. When there's only one way to analyze the data and there's no other possible way you could possibly analyze the data. But that's false, isn't it? There are multiple ways to analyze the data. And when you talk about ontology, there are actually 4 ways. There are 4 ways to analyze the data. Monism and dualism are 2 ways. The other 2 ways are idealism and physicalism. The mainstream physics today are physicalist, but they haven't always been physicalist. In fact, it's brand new. The physicalism in physics is brand new, only within the past few decades. In fact, any old physics professor, old physicist, ask them what they think, and their beliefs are the same as when physics wasn't physicalist. It was monist. Physics was monist, like a few decades ago, 50 years tops. Really, really not that long ago. And for 99% of the history of science, it was monist. Okay? So if you ask, basically, we're going to talk about energy and energy flow, what I think about that concept. Energy flow. Generally, if you ask an old physicist what they think about energy, they'll basically give a monist answer, which is, well, there's an objective reality, there's like a fabric of reality, and things actually happen in objective reality over there. That's stuff is going on over there. And the name we give that is energy. That's the name we gave that. Energy. That's the label we call it. There's actually stuff going on, and we call it energy. Today they don't do that. They don't do that anymore. If you ask a physicist today what they think about energy, they say something completely different, which is that, well, energy, it's like a construct. It's not like a real thing. It's just, they say, well, the word energy, that's a construct. But no, they're not talking about, yeah, everyone knows that the word, like you can call anything you want. As long as you are on the same page and you picture the same thing in your mind, doesn't matter what you call it, everyone knows that the actual label you give something, that's the construct. That's not what they're saying. It's like an excuse for them. They actually believe that there is not something really going on there in objective reality. They actually do not believe in objective reality. That's why they base their theories now off of only math and equations. They think that you can write equations down on a piece of paper and be gathering data from like a black hole. They literally believe that. But really, all math is analysis. It's a study of the way we think. That's all math is. It's a form of psychology. It's an analysis. Mathematics is not data, but they don't believe in minds either. And, it's okay if they study the mind, because the mind is reflective of physical reality, but they don't believe in physical reality. It's so twisted, and they don't know how to answer. They don't know how to conceive of something abstract like energy. So they just say, oh, well, energy is, the word energy is like a construct. They say the same thing about fields. That's why when this YouTuber guy, the Asylum guy, he shows the fields as being like a characteristic of space, like the vectors stay in one spot, in their predetermined spot in space, and then like the battery or whatever moves and affects that, it like moves by the field. No, that completely contradicts all of the history of monist science. For example, it's been a known fact for a long time that a whole bunch of different materials have the capability of being a magnet. And philosophically speaking, all matter, all materials have that inherent characteristic. It's an inherent characteristic. It's not it's not a construct. It's not lines drawn on a piece of paper. It's not a characteristic of space. No, it's the field is a characteristic of the battery or the magnet itself, whatever. Saying that there are inherent characteristics to all matter, and then saying that the field is like a construct that's also a characteristic of space, that's why the mainstream physics is wrong. Okay, their data is good. They got perfect data. Okay, that's not the issue. The issue is that they're not allowed to think. They're not even allowed to think about these questions, about metaphysics. That's the issue. They're discouraged from thinking. and it's dogmatically enforced. Of course, the people at the top know what's going on, but that's another issue. Okay, so physicalism, that's the brand new mainstream physicalism in hard sciences. That's one way to analyze something. That's one way to analyze the data. The data is perfect. The data is, you can't change the data. Everyone's got the same data. But there's 4 ways to analyze the data. One is physicalism, and they say that energy is a construct. It doesn't really exist. And this philosophical stuff doesn't even matter. Another way to analyze the data is that, well, everything's just a dream world. That's called idealism. Everything's a dream world. I'm God. I'm dreaming up everything. Of course, there's no such thing as energy because I'm just dreaming things that are happening. Okay, that's idealism. That's the soft sciences. That's like sociology bullshit. It's a dream world. So that's another way. That's an alternative to the mainstream physics. Just saying everything's a dream world. Okay, so that's one way to analyze the data. Another way to analyze the data is dualism, which says that characteristics are separate from matter, from materials, which that's proven over and over again to be false. So one way you can think about this is, well, it's the field or the pressure or whatever, the energy. The energy is, it's like a ghost substance over there that does whatever it wants. It's like another element, and you can like hold it in a jar and you can like pour it out or something, or it's like gaseous, and you can do stuff with regular, like real physical matter, but then you can also like take the energy away from it, and like it's like a substance. That's dualism. Or you could think of it as like ghost particles, which is similar to physicalism. What when you say vortexes, what does that mean? You're trying to explain something that's happening, and yet you're imagining something brand new that also has to be explained. Vortexes means that there's a medium, and a medium means that it's made up of particles or some kind of ghost substance. So just saying that everything's made up of vortexes doesn't explain anything. It literally, okay, yes, vortexes exist in nature. Got that. But why do vortexes exist? Okay? That's why you have to listen to Ken Wheeler when he talks about the differences between monism and dualism. And even Ken Wheeler kind of flubs things a little bit by using certain terms that would confuse people that are not as an expert, not used to thinking in this particular way. Like if you say pressure, if you say the word pressure, it's kind of like pressure from gas or something, like the helicopter is pushing air molecules down and it's being lifted up. That's pressure. You're talking about a medium with particles. So I would stay away from the word pressure and anything that's like that. It's like talking about pressure in vortexes is like saying, it's basically the same as saying that there are little light bullet photons shooting out of a light bulb and hitting something. Basically the same thing. It's physicalism or dualism or something. Like it's no, like monism is the correct alternative because it actually explains things. Mainstream science for most of science has been monist. Okay, it's only the brand new physics which is dumb and dogmatic. So and that's why it's dumb. It's because it actually contradicts the majority of what has been learned in science. And all of these theories sound very, very similar to each other. And see, that's why it's so important to think clearly about exactly what the alternatives are and which one is correct and why. And once you go through that process, the correct answer is most likely going to be monism. And then talking about vortexes and all this stuff won't make as much sense. Another thing about vortexes is that that word is kind of based off of the geometry, what is thought generally to be the correct geometry. And that I also have an issue with. Again, Ken Wheeler has mentioned a few times that the geometry is based off of there's a model for the geometry. It's called the Poincaré disk model. And he's mentioned that title a few times, but he hasn't gone into exactly why. That's important. The Poincaré disk model is important. Why is it important? I think that needs to be stressed a lot more. Because it actually, it doesn't, to talk about the Poincaré disk model and then say, well, it's like, when he talks about the Poincaré disk model, I agree with him. I think it is similar. It's similar to that. Ken Wheeler, if you're listening to me, hello. The disk model is it's a model of stereographic projection. Particularly with it's kind of has like a boundaries to it. Generally there's like no boundary to it. It doesn't really matter. That's a topic for another time. That's more specific, but really you're talking about stereographic projection. That's stereographic projection, and stereographic projection does not mean a toroid with a vortex going down into the center of it. There are multiple models showing what stereographic projection looks like in 3D. A fourth dimensional sphere being stereographically projected as a three-dimensional object, meaning that it exists in objective reality as a fourth dimensional sphere, but if you perceive it in 3 dimensions, then it has a particular shape. So this sphere, this fourth dimensional sphere, is a sphere. We're talking about geometry here. It's not made up of a substance. It's not a particle. It's geometry. That's all it is. Nature has already described things. You don't need to add anything else. Okay, so it's a fourth dimensional sphere made up of lines, straight lines. Okay, so there's a bunch of different ways to make a sphere with lines. One way is with at 0 degrees, and then there's orthogonal to that, 90 degrees. There's you can make another set of lines. Okay, so those are all straight lines, and anywhere in between from 0 to 90 degrees, a straight line, an actual straight line, and that whole set of angles of lines around that fourth dimensional sphere makes up the sphere. All these different characteristics, that's what the line angle represents, is a different characteristic. So magnetism, electricity, and then all the other characteristics in between. So they are straight lines around a sphere, but because you're not able to perceive the fourth dimension, then there are distortions. The lines are now curved, and they distort. They appear distorted in a particular way, which is in line with stereographic projection. There are a bunch of ways to envision that, and I don't think a toroid or torus, whatever, with a vortex is correct. I don't think it's the best way to visualize. I think it's similar to that, but it's different. So look at this real quick. So this that I just showed you, it is a it's called a fibration, Hopf fibration. And so all these lines, these fibers, are going off into infinity. That's really what a field is. You just saw what a field. That's what a field looks like. And those lines represented a particular angle. Whatever angle they used, I don't know, but it represented a particular angle, probably in between 0 and 90 degrees, because those lines were spirals. And that's like what you see in the ferrocell is the spiral. That's what you see in the sunflower. It's a spiral. It's a field. It's the result of a field, which is a line somewhere in between 0 and 90 degrees, which is stereographically projected into our three-dimensional reality. Okay? All these fields are working against each other. All there is fields. They all want to cohere, but they're all working against each other. I don't know why. That's just, things are jumbled up, okay? They're all working against each other. Like, they're kind of like rubber bands. They bend and stuff. You can actually see it. When you take another magnet near a magnet and you're looking at it through the ferrocell, you can see the lines bend. They're kind of like magnets. Rubber bands. The lines are kind of like rubber bands. Not because they're made up of something, but because the geometry, the field, that particular field, is one of those lines. In the geometry, it's geometry, okay? And it wants to cohere because it's of geometry, and there's nothing else more to know about it. There aren't like little vortexes. Okay, that's it. That's the end. So if you have a magnet on one side of the table and a magnet on the other side of the table, and you move one magnet around, you can't really see it move the other magnet around. You're not really moving it around, but it is influencing it a little bit, slightly. Why is that? It's because those lines that are shooting off into infinity are actually connected to each other. They're really connected to each other. And if there was a magnet on the other side of the world, well, heck, lines from this magnet are hooking up with lines from that magnet, and they're actually influencing each other like a little bit. Infinity. Okay, and it's just a bunch of lines all over the place. Just a bunch of geometry lines and a bunch of different angles. So if you have an object, and you have two pairs of rubber bands, and you're pulling the rubber band this way, you're pulling a rubber band this way, and the object is suspended in the middle here, and it's not going anywhere, even though this field rubber band wants to go this way, and this field, this characteristic field rubber band wants to go that way. And if you cut one of the rubber bands, then the object is going to go flying that way, because it was enabled, something cut that field off and enabled that field to cohere. Everything wants to cohere. See, that's why you have to so like when you make a magnet, there are all these in a chunk of iron, there are all these particles that are going all these different ways. And there are these little domains that are coherent. They are aligned, and that's proof that the magnetic fields want to cohere, but they don't automatically cohere, because there are other fields that are coherent and messing up the magnetic fields. And so when you throw that chunk of iron into a solenoid and influence the material with the electric fields, you're basically snapping off that whatever other rubber band kind of field that was, and you're allowing the magnetic fields to cohere, and they all snap that way really fast in the same direction, and they cohere. And I think that's what a circuit is. I think that the all of these materials, the battery, the wire, the light source, or whatever, I think they all want to cohere. They're coherent in one way, but they all have fields that want to become coherent in another way. And I think that's the circuit is simply a way to arrange the materials so that those particular fields, those particular characteristics can become coherent. The energy, where does that come from? Well, the energy is inherent in the materials in all of the materials themselves. The energy is coherent. It is the fields working against each other. The fields working against each other, that's the energy. If there's not really energy, it's just the geometry, different opposing geometries, different geometries that are coherent or incoherent. And like the solenoid, the circuit disrupts one set of characteristics and enables another. And another thing is, so there isn't anything flowing. That's kind of like what I'm trying to say. I don't think there's anything flowing. I think that the inherent characteristics within the materials themselves simply want to cohere. Nothing's actually moving around. The lines are simply changing. That's the thing. There's a change in geometry. It's a change in a location and in orientation of physical objects. That's all energy is, I think. And like if you have a magnet here, and if you move another magnet this way, then this magnet wants to move to follow it to become coherent. So where does that energy come from? It's just things are moving through space and time. That's another thing. Time. This geometry, you can believe whatever you want about the weird 11-dimensional string BS, but the actual geometry of a magnet proves that a fourth dimension exists. And maybe you and I experience it as time, but in a way it is a physical coordinate. So you identify the middle of something as counter space. However, I don't know if I would call that the center of it counter space. I think that is the particle itself, the actual location, the three spatial coordinates, the actual location of the fields, the object itself. And it also has a fourth coordinate to it. Where is that fourth coordinate? It's not here, it's not there. It's actually in every direction in infinity. Again, we're back at stereographic projection. Just to understand the fields, to understand the geometry, read about, study stereographic projection. I guarantee that is correct. I guarantee it. That's, us talking about this, we are not the people we're not just like making this stuff up. This is old stuff. This was stuff that monist science found years ago and is now ignoring, denying. Yeah, I think that's all I wanted to say. So